Next up, we have circles. And to start us off, I have some basic information on circles. The first one is that a line extending from the center point to the edge of the circle is, of course, your radius. And then a line extending from one end of the circle to the other end of the circle, but passing through the center point, is your diameter. And you should also notice that your diameter is like two radiuses or radii. Wait, doesn't matter. Two of them put together, so your diameter is just equal to 2r. And you should also know that the diameter splits the circle in half. Then we have the equation of a circle, which is going to be x minus h squared plus y minus k squared is equal to r squared. And there's two things you can get from this equation. The first one is that hk is going to be your center point. And the thing to notice here is that it's minus h and minus k in the equation, which means that whatever number you see there, it's actually going to be the opposite sign. And then r is your radius, and the important thing to notice here is that it's r squared in the equation, so you're actually going to have to take the square root of whatever number to get your radius. Here's our first example, and first, to find the radius, we know that 16 is r squared, so to find the radius, we have to take the square root of 16, which is 4. And then to find our diameter, we know that our diameter is 2 times our radius, so 2 times 4 is 8. And then to find our center, that's going to be hk. So h is negative 3, but remember, you have to take the opposite sign, so it's actually going to be positive 3 here. And then k is positive 2. We take the opposite sign, and we get negative 2. So our center point is going to be 3, negative 2. Then, here's a harder example because it's not in that standard form equation of a circle. You know what I'm saying? So let me show you how to do this in Desmos. Alright, here I am on Desmos. And the first thing you're gonna do is type in that equation. So here I just copy and paste it for time's sake. And this is our circle. Now if we click on our circle, a few points will pop up. First, the x-intercepts. Then there's the y-intercepts. And there's also these two endpoints. And these two endpoints lie on the middle of the circle, so they're exactly in the middle. Whenever you want to find the center point or the diameter or the radius, always make sure that you're using these 2 points. Never ever use the x-intercepts or the y-intercepts, so be really careful to spot that. Alright, the first thing we're gonna do is find our center point. Now, we know these two endpoints lie directly in the center of the circle, which means that the very center point of the circle is just the middle or the midpoint of these 2 points. So what I'm trying to say is you can use the midpoint formula to find the center. Now, I don't know what the midpoint formula is, and I don't think I ever want to memorize that, so you can just use Desmos. If you type in midpoint and then parentheses, then let's type in our first point, 3, 2, comma, our second point, 3, negative 6. It gives you the midpoint, which is going to be 3, negative 2. And that's also going to be the center point of our circle. Now, to find our diameter, isn't that really just the distance between this endpoint and this endpoint? Once again, you could use the distance formula, but I don't know the distance formula, but Desmos does. So you can just type in distance, and then same thing, just type in your endpoints. I'm just copy and paste that. And we get that the distance between these 2 points is 8, which means that our diameter is also just 8. And then we know that our radius is just 2 times our diameter, so we do 8 divided by 2, we get that our radius is 4. So that's how you find the center point, the diameter, and then the radius. But of course, if you wanted to, you could like find the distance between this endpoint and the midpoint. So like if you did distance, and then that, and then that, you would still get that the radius is 4. Now the number one thing to do on all geometry questions, it doesn't matter if you're solving for squares, triangles, circles, don't matter. Whenever you're on Desmos or have a graph, please don't count squares. Like, let's say I count squares here. 1, 2, 3, 4, 5, 6, 7, 8. You would get that your radius would be 8, but your radius is literally half of that. So like, don't count squares. I also forgot that you could like zoom in Desmos. So like, if you zoomed in a lot, then your squares would be like infinitely more. Or if you zoomed out a lot, then you'd have like even less squares. So just don't count squares ever. Moving on from equations of circles, we have arc length. Now you can use this proportion here to find it out. The length of an arc over the circumference is equal to the central degree over 360 degrees. Now this is also equal to just the circumference times the central degree over 360. So whatever way makes it easier for you, you can use that. Now I don't think you need to know how to find the area of a sector, but if you did, then all you really need to change is just change circumference to area. So here, instead of length of arc, it would be area of a sector, and instead of circumference, it would just be area of a circle. And then same thing here. The central degree over 360 would still stay the same. Here's our first example for arc length, and we know that our central degree is 50 degrees, so we can go ahead and plug this in. And we also know that our radius is 6. So for our circumference, we know that that's going to be 2 pi r, and then our radius is 6. So we can go ahead and plug that in for r. And now we can just multiply 2 and 6 together to get our circumference of 12 pi. Now instead of just keeping it as this whole like chunk of text, let's just make a length of arc x. And now we can cross multiply. So 360 times x and 50 times 12 pi is equal to 360x is equal to 600 pi. And then we get x by itself by dividing by 360 on both sides. And we get that the length of this arc is going to be 5 over 3 pi. Lastly, we have radian conversion. Now I'm pretty sure this is like on the bottom of the reference sheet where it says that 2 pi radians is equal to 360 degrees. But this is also an equation that you can use to convert. So to get radians or to convert from degrees to radians, you're going to multiply your degrees by pi over 180. And then to get degrees or to convert radians to degrees, you're going to multiply your radians by 180 over pi. So if you notice, all that changes is that the pi and the 180 are just swapped. One final thing that I want to point out is that I just said that 2 pi radians is equal to 360 degrees. So if the question is asking you in terms of radians, you can just swap this 360 degrees for 2 pi, because they're both the same thing. Alright, and that's gonna be all for circles. Now that was a lot. Like, you have to memorize the equation of a circle, and then you have to memorize this equation, which is length of an arc. And you also need to memorize the radian conversion. So there's definitely a lot of equations that you need to know. So hopefully, as you do more practice, you'll be able to get more familiar and more comfortable with solving for circles.